Hello everyone, good evening.
Good evening, sir.
Good evening, sir.
Yes. Yeah, so today we have solved the session for week 9. Have you all covered the week 9 or still preparing for the quiz, focusing on week 1 to 8 only?
Focusing on quiz only.
Okay. So how is the preparation?
Going well, sir. Still lot more practice to go.
Which
Sir,
yeah,
before quiz 2, is there any revision session?
revision session we have just conducted, right? For week 7, 8, it was conducted on Sunday, and week 5, 6 also we did earlier, right?
So the combined 4-week session can't be there.
Combined 4-week session, it gets too lengthy, 4 to 5 hours. That's why we split it into 2 parts. Right? We will have one mock session on Thursday, and we will be having on-demand session focusing on week 5 to 8. If you want one live session on it, we can also conduct that. It's not an issue.
Sir, when will state's mock test will release?
It will reach tomorrow morning around 10 a.m. It will be released, and it will be available till 5 p.m. on Thursday.
Okay.
So in which week you guys are facing more difficulty, like 5, 6 or 7, 8?
8.
Permutation.
Conditional probability.
Okay.
Yes, sir.
So week 7, 8 are of major concern for you guys for now, right?
Permutation combination is okay, but if there is a question of conditional probability, then it's been little bit hard for.
Okay.
So the
Okay, so-
assignment submission deadline can't be extended in week 9.
Week 9, I'm not sure about it. If it will be extended, you will be informed about it. But for now, there is no extension on week 9 deadline.
Sir, can we expect any more discussions on week 9 post quiz 2?
Week 9 discussion post quiz 2. Yeah, if we can have it. See, on-demand session we will always be having on previous weeks, right? Even when we are in week 10, 11, we will be having some on-demand session from week 1 to 8 on that, right? Week 1 to 8, 9, 10. So the purpose of on-demand session is to just cover those lagging concepts which you weren't able to do on time.
Okay, sir.
So how many of you are attending on-demand sessions?
I have attended also.
Okay, so which session you find more interesting, the live one or the on-demand, or both are same?
I found that Prashant sir revising week 8 very helpful, and the last night Rahul sir. It was also very useful.
Okay, so yesterday I think we have covered week 7, right?
Right, sir.
Yeah, so we will have one on week 8 as well. Planning on it. Yeah, we will inform you on Telegram group regarding that as well.
Sir, can we have recording for yesterday session?
For on-demand session, there is no recordings.
Because the session is too late, so I'm.
Session is too late. Okay, so we will do it. We'll keep on changing time for it. So in my previous session, I asked you all what is the convenient time for on-demand. So I think most of you have said 10 to 12. That's why we have scheduled it at 10:15. Next one, we will schedule it something around evening. We will schedule one.
Okay, sir.
Okay, so I think by now you all are aware of the instructions for solving the session. So for those who are not, just keep a notebook and pen with you. For each question, you will be given some time around 5 to 15 minutes. And to answer the question, you have to open a new browser or new tab in your current browser and go to joinpd.com and enter the code shown on the right top of your screen, which is AZA BJH. So if you're using it on your laptop, your view will be something as shown in the left side of the screen. And if you're using it on mobile, your view will be as shown in the right side of your screen now. So for mobile users, you will have to click on answer question to answer it. While for laptop and desktop user, you can simply answer it. It will be shown on your side, right side of the screen to answer it. And on the left side, you will be seeing the question. Okay. So moving further. So yeah, random variable. Are you guys aware of what actually is random variable by now? You guys know what is variable? So random variable is same as kind of variable, but it is a variable we associate with a random experiment. So we name it as random variable. So suppose I have I'm tossing a coin. So either I could have head or tails. So instead of looking at observation head or tail, what I am doing is I'm assigning a variable to it along with some values. Like if I get heads, it will take value 0. If I get tails, it will take value 1. You can assign any value to it. It depends on you and what are your purpose of assigning it. We will cover that as well. So in general, we have two types of random variable. One is discrete and one is continuous. So it is mostly same as what you have done in the week 1, where you identify whether the variable is discrete and continuous. It's the same way to identify it. If it is taking some countable values like 1, 2, 3, or some 1, 1.5, 2, but it cannot take any in between values, then it is a discrete random variable. As an example, number of people in a household. It can be either 1, 2, 3, 4, and so on, but it cannot be any other number in between these, right? There cannot be 1.5 people like that. While in continuous random variable, it is same as continuous variable, where it can take any value in an interval, like amount of tea in a glass. So it could take any value from 0 ml to the capacity of glass. If it's 500 ml, so it can take any value between 0 ml to 500 ml, right? Is this clear?
Yes, sir.
Okay, so moving forward to first question. So here we have 3 following definitions assigned to a random variable. So suppose your first random variable is denoting the number of spelling mistakes in a report. The second random variable is time taken by a person to write an exam. And your third random variable is weight of a person. So you have to identify which of the following is a random variable. Either A is a random variable, or B, or C, or none of them is a random variable.
Discrete random variable, right, sir?
Yeah, you have to identify which of these 3 is a discrete random variable. Okay, so all of you have answered option A. So yeah, number of spelling mistakes in a report. Yeah, it is a discrete random variable because it can either take value 0, 1, 2, and so on up to the number of words in a report, right? But it cannot take any in between values. Like it cannot take any value between 0 and 1 or 1 and 2. While B and C are continuous random variable because it can take any value within the specific interval of time, right? So by the definition, it is clear that option A is correct. Okay. So moving further, probability mass function. The probability mass function is something we define for a discrete random variable. And if it is continuous random variable, it becomes probability density function. You will cover such things in week 12. So probability mass function basically tells you about the probabilities to each of the assigned values of the random variable. So suppose I'm tossing a coin and I'm assigning the value of random variable 0 if the outcome is head and value 1 if outcome is tail. So if I assign the probability to these, suppose it's an unbiased coin, then the probability that X will take the value 0, which means I get head as an outcome, it has probability 1/2, and it has tail as an outcome, it will have 1/2. So for each value of random variable, I have assigned some probability. So such thing is called probability mass function. And it has two specific properties which are to be followed. One is that each of the probability assigned should be greater than or equal to 0. And second one is if I sum all those probability which are assigned to all the possible values of random variable, their sum should be equal to 1. Okay. Is this thing clear or any doubt in it?
No, sir.
Okay, so your second question is, so your X is a discrete random variable and it takes value 0, 1, 2, 3 and so on up to infinity it can go. So by applying the properties of PMF, you have to identify if it is a PMF or not. So in general, you need to check the following two properties. One is that each of the probability should be greater than or equal to 0. And second, their sum should be equal to 1. So if these two properties are satisfied, it would be a valid PMF. Is it done or you guys need more time to solve it? Or do you guys need more time?
Done, sir.
Okay. Okay, so yeah, let's move to a solution. So yeah, so each first property is that each of the value of probability should be greater than or equal to 0. So yes, my 5/6 times 1/6 raised to the power x will always be greater than or equal to 0 for each of the values of x. Next thing we need to identify is the second property. Second property is the sum of all the probabilities assigned to this random variable should be equal to 1, right? So suppose I draw just probability mass function for this. So if x takes the value 0, then the probability mass function would be 5/6 times 1/6 raised to the power 0, right? For 1, it would be 5/6 times 1/6 raised to the power 1. For 2, it would be this, and so on up to infinity, right? Now, in general, what is happening is we are summing it from I goes from 0 to infinity, 5/6 times 1/6 raised to the power I, and it should be equal to 1. So if our this condition is satisfied, if it comes out to be equal to 1, then it would be a valid PMF, right? Because my first property is already satisfied and we are checking it, right? So on solving it, since 5/6 is a constant, it can come out, right? So I goes from 0 to infinity, 1/6 raised to the power I. So are you guys aware of formula for infinite geometric progression or infinite GP?
Yes.
Yes,
sir.
Yes, sir.
1 divided by 1 minus r.
A by 1 minus R.
A 1 by minus R.
So here my A would be the first
One.
term, right? 1/6 raised to the 0, right? And 1 minus my common difference is 1/6, right?
Yes, sir.
So it comes out to be 5/6 times 1 times 5/6. So it
5/6.
comes out to be 1, right?
Yes.
So my second property is also satisfied. Since both of these properties are satisfying, it is a valid PMF, right? Any doubt in this? Anyone?
No, sir.
Sir, any short way to deduct this?
Can you repeat?
Any short way to reduce this thing that it would be equal to 1?
I think it is the shortest way I did. There won't be any other. I'm not sure if any one of you I know any shorter way than this. It's only a two-step question, right? For the second property. You only need to sum it up and we need to use the property of infinite GP, right? That's only in general or one or two-step question. So let me see your response. So 15 of your answered. Okay, great. Okay, so yeah, any doubt in first two questions till now, anyone?
No, sir.
No, sir.
Sir,
Yeah.
sir, I didn't understand PMF very clearly.
You
Means
understand?
operation is clear, but basic definition is not clear.
Basic definition. Okay. Okay. Suppose you are performing some experiment. Okay. Let's say I'm tossing a coin twice. Okay. So what all are my possible outcomes? I could get either both heads, right? Or head tail, tail head and both tails, right? Let's say I define a random variable x, that is number of heads I get. So in such case, what value will your random variable take? For the first possibility, there are two heads, right? For second one, your random variable will take only value 1 because there is only one head in this, right? Similarly, for the third one, it will take value 1. For the last one, it will take the value 0, right? So in general, the possible values your random variable can take is 0, 1, and 2 only, right? So now if I assign the probabilities to each of its possible value 0, 1, and 2, such that each of the assigned probability is greater than or equal to 0, and if I sum it up, it should be equal to 1. If I can assign the probabilities in such a manner to these three values, then it would be a probability mass function. So in general, what it does is it tells you about the distribution of probability for each of these values, right? Like for 0 heads, it should be, you should get both tails. If it's an unbiased coin, so it would be 1 by 2 squared, right? Similarly, for 2 heads, it would be same. And for 1 head, it would be 2 times 1 by 2 squared, right? So it tells you about how the probability is distributed throughout for each of the possible values of random variable, just like we did for sample space, right? Sample space, we assign probability to each of the possible outcomes, right? But we do it same for the random variable, discrete random variable. It is called PMF. Is it clear?
Yes, sir. Thank you. Yes, sir. It's clear.
Okay. Okay, so moving further, so random variable x has the following probability mass function. Okay, because I can see it's a discrete random variable taking values 0, 1, 2, 3 up to 7. And it takes the respective probabilities 0, k, 2k, so on. So I need to find the value of k. So only thing which is given to me is it is a discrete random variable which can take the values 0, 1, 2 up to 7. And I know their respective values in terms of k, and I know it is a valid PMF. So by using the properties of PMF, I can compute k in some sense, right? So just give it a try. So do you guys need more time in this? Shall we increase the timer or done with it?
Done with it, sir.
Okay, let's just wait for 30 more seconds and then proceed.
Sir, in questions like this, would the value of k always have to be a natural number, or can it be like decimal or something like that?
It can be anything, but both the properties should be satisfied. That's the only condition, right?
Okay, just clarifying. Thank you. Thank you, sir.
Okay, so yeah, so I'm using here my second property of PMF, which is if I sum up all the probabilities, it should equal to 1, right? So adding them all up, like 0 plus k plus 2k plus 2k, then plus 3k, then plus k square plus 2k square plus 7k square plus k, it should be equal to 1, right? So that's the first equation we have written. So on simplifying it, we get something 10k square plus 9k minus 1 equal to 0. And then you can obtain the value of k by finding the solution for this quadratic equation. So your k comes out to be 1 by 10 or minus 1. So now notice that if I put k equals minus 1, right? So if k equals minus 1, then for x equals 1, my probability would be minus 1. So my first property of PMF would be violated. That is, each of the assigned probability should be greater than or equal to 0. So minus 1 is not the one of the possibilities for k equals for k. So k can only be 1 by 10. Okay. So if you put k equals 1 by 10, you will see that both the properties of PMF will be satisfied. Their sum come out to be 1, and each of the probability would be greater than or equal to 0. Is it clear or any doubt in this question?
Clear, sir. Clear, sir.
Okay, so for next 1 or 2 question, just keep the value of k noted down. It's 1 by 10. Using this, we will solve the next 1 or 2 question. Okay. Okay. So next question, it's the same probability mass function given to you. The value of k you have already obtained in the previous question. You have to find out what is the value of probability that x takes the value less than 6. Okay. So one most common mistake that students make is they consider 6 as well, while the question is asking for only less than 6. So it's 0, 1, 2 up to 5 only, right? Okay, let's
Excuse me, sir.
yes.
Sir, can I ask a quick doubt of week 6?
After
Yep.
these slides, we will go to these topics.
Excuse me, sir. Sir,
Yes.
actually, I'm not able to view this question on joinpt.com. I'm getting a message that your teacher has locked responses for this slide.
For the current, you are on prelude 2 to question 3. Is this the same question it's showing?
No, it's not showing the same question.
Can you just refresh it once? Because
Yeah,
it should show you this question. Yeah.
yeah, got it. Thank you, sir.
Hello. Hello.
Yes.
Hello, sir. Sir, I have a doubt in week 9, activity 9.4. Sir, can you please explain?
After these slides, we will move on to these questions. First, let's focus on the current slides only. Okay.
Okay. Thank you, sir.
Okay, so let's move to the solution part. For that, okay. So we already know the value of k, it's 0.1, and we need to compute the probability x less than 6 only, not equal 6. So probability x less than 6 means x can take either value 0, 1, 2, up to 5, right? So if I add the probability for these 6 values, 0, 1, 2, and 5, so I will get the probability that x will take the value less than 6, right? Any doubt in this, or is it clear? Clear, everyone? Or any doubt?
Clear, sir.
Yes, sir.
Yes, sir.
Okay.
Yeah.
Okay, so that's the same question. Another question based on same probability mass function given. So here you have to calculate the value that the probability of x taking the value greater than 0 but less than 5. Okay, so just try to find out which all values will fit in this and add the probabilities. Okay.
So the same k value should be used.
Yeah, it's the same probability mass function. So the value of k would be same, right? Okay, let's move to the solution part. So x taking the value greater than 0 and less than 5. So the possible values which will lie in it is x equals 1, x equals 2, x equals 3, and x equals 4. Yeah.
Can you just unlock for 30 seconds?
Okay, it's already done. So yeah. So you just add these 4 and you get the value 8 by 10, which is nothing but 0.8. Okay. Is it clear? Any doubt in this question till now?
No, sir. No, sir. Clear. No doubt.
So what we have done for this question is, so in whenever you will see a question, you will see actual question like this only. You have to calculate the value of probability within some range of x. Okay, so these are just the steps which we did. So first what we did is, first you have to compute the value of k. As soon as you find the value of k by using the properties of PMF, you can simply use it. So these are just the 2-step question, which is we have split it into 2 parts. Okay, but actual question would be this. So the first step is use the properties of PMF to obtain the unknown value and then proceed further. Okay.
Yes, sir.
Okay, now moving on to next question. Okay, so Naman has to give 3 mock tests. Okay, so the probability that he will not give any of the mock test is 1 by 8, and the probability that he will give 1, 2, and 3 mock tests are 3 by 8, 3 by 8, and 1 by 8 respectively. So we are assuming x to be a discrete random variable which represent the number of mock tests given by Naman. So the possible values of x, I think you all can relate from the question. If it doesn't give any mock test, so it would be 0, 1, 2, and 3, right? So these are the 4 possible values for discrete random variable x, which represent the number of mock tests given by Naman. So you have to find the probability that he will give at least 2 mock tests. Okay, so at least 2. Now we have moved on to word problems. So from this question, first you need to identify what does at least 2 mock test would mean in terms of your random variable x, and then compute the probability. Okay.
Sir, do these kinds of questions from exam?
Can you repeat?
Do these types of word problems also appear in exams?
Yeah, week 9 will be part of quiz 3. So in general, you will be given, like most of the cases, you will see word problems only. Those given tabular format is just the basic thing from which, like, you have to get this word problem in terms of that only to solve. Yeah.
Hello, sir.
Yeah.
Sir, from this question, can I conclude that the probability of 0, 1, 2, and 3 are given?
Yeah, it is given to you, right? The probability he will not give any mock.
Not means 0.
0 mock is, so x equals 0 is 1 by 8, right?
Then 1, 2, and 3 also are given.
Yeah.
Okay. We have to calculate at least 2. That means 0, 1, 2.
That's what you have to think. We will discuss in a minute. Solution.
Sir, is that just to clarify, they say that the probability that you do 1, 2, or 3 mark tests, are they the test numbers or the number of tests?
The number of mock tests.
Number of mock tests. Okay.
Yeah.
Just clarify. Thank you, sir.
Yeah. Okay.
So week 9 is not part of quiz 2 now.
No, week 9 is not a part of quiz 2.
Because earlier you stated that week 9 would be part.
No, week 9 is never part of quiz 2. Week 9 to 12 it will go in quiz 3 along with week 1 to 8. Okay, so yeah, most of you have answered 5. Okay, see, so one of the common mistakes, I think, I won't take the name, but yeah. So at least 2 doesn't mean 0, 1, 2. At least 2 means 2 or greater than 2. So that means you will give either 2 mock tests or 3 mock tests. If it had been at most 2 mock tests, at most means less than or equal to that value. And at least means greater than and equal to that value. So at least 2 mock tests means your x should take the value either 2 or 3, right? So if I add these two, I will get 3 by 8 plus 1 by 8, which is 1 by 2 or 0.5. Is it clear or any doubt in it till now?
No, sir, clear.
Okay. Okay, so moving further, now we have computed we know about the PMF, we have covered this concept. So moving on to CDF, cumulative distribution function. So cumulative distribution function, it tells you the value that your random variable takes the value less than or equal to some specific value. So it is denoted by capital F. So if I say capital F and 2 in place of x, it means the probability that my random variable will take the value less than or equal to 2. Okay. And it also has two properties. First is that the maximum value it can take is 0 and minimum it can take is 1. So its value lies in between 0 and 1, including both 0 and 1. And second thing is, if my x2 is greater than x1, then the CDF of fx2 will also be greater than CDF of x1. So what does it mean is, suppose your x2 is 2 and x1 is 1. So your f2 would always be greater than or equal to f1. Okay. So it in general, it will keep on increasing as the value of x increases. Okay. Will increase or remain the same. That's the main thing to keep in mind. Its value will never decrease with increase in x. Okay. Any doubt in CDF?
Sir, please explain once more. CDF.
Okay. Okay, so CDF means cumulative distribution function. We denote it generally by capital F and this value x. So it means that the probability that your random variable will take the value less than or equal to this value x. So in general, suppose your random variable takes some value 0, 1, 2, 3. Okay. And if I say you have to compute f of 2, it means you need to find the probability that your random variable takes value less than or equal to 2, which is x equals 0, x equals 1 plus x equals 2. Okay. And it has two properties. Property 1 is that its value will lie between 0 and 1, both included. It will not go below 0 and it will not increase the 1, because the max you can do is, even if you do f of 4 in this, so it would mean probability x less than equal to 4, but it would be the sum of all these probabilities, right? So its value would be, and then comes out to be 1. It won't increase, go past 1, right? The second property is, if my number x2 is greater than x1, then the value will either be greater or equal to the value of CDF for x1. For example, if I take x1 as 1 and x2 as 2, it means that f of 2 would be greater than or equal to f of 1 always. So what it means is, as my value of x keeps on increasing, the value of f of x will either increase or remain the same. it will not decrease with increase in x, right? Is it clear?
Yes, sir.
Okay, let's move to the question. So yeah, you are given a discrete
sir.
random variable. Yeah.
Sir, at last, if you have time, can you please explain the conditional probabilities? Sir, I'm able to follow that in the sums.
Yeah, after the slides, we will
Okay, sir. Thank you. Thank you, sir.
Okay. So you are given a discrete random variable with the following probability mass function. Okay. And you need to calculate the value of capital F of 3. So it's kind of merge of two questions. You know it is a valid PMF, so you can use the property of PMF to find the value of K. And after that, you have to compute F of 3. Okay.
Sir, is there any mock test, sir, for quiz 2, sir?
Yeah, there is a mock test for quiz 2.
So did they send any mail? Because I haven't received any mail, sir.
Okay, we will send the mail for it, but yeah, it will be released tomorrow morning around 10 a.m. and it will be available till Thursday 5 p.m.
Oh, okay, okay, sir.
And then Thursday 6 p.m. onwards, we have a mock session, right?
Okay, so because I haven't received any mail, I mean, for any maths or statistics or for CT, sir, also. So that is
it's for stats when I'm telling. So you will receive a mail along with it as like it's released, and then you will receive a mail that it is released. It's like that.
Sir, in calendar, tomorrow
Yeah.
qualifier attempt session is going. What type of session is that? Revision session for qualifier attempt?
It's not for you
Re-attempt.
guys. It's those who weren't able to clear qualifier this time, they had a chance to reappear in qualifier. So it's for them only.
Okay.
Okay, let's just increase the time for this. And most of you are still doing it.
Sir, there is a mail for change of grading pattern, but cannot understand what it is it exactly.
For that, you have to ask the support team. You can mail them regarding it. Okay. Are you guys done with it or need more time to do it?
Done, sir.
Okay. Okay. So see, in general, what we need to do is to compute the value of f of 3. It means that I need to find the probability that x will take the value less than or equal to 3, right? Which means probability x equals 1 plus probability x equals 2 plus probability x equals 3. But I will get this probability in terms of k. So first I need to find the value of k. So by using the property of PMF, that sum of all the probability should equal to 1, right? So I put the sum equals 1. From here I obtain the value of k, which comes out to be 1 over 8 or 0.125. And then I can plug it in the expression obtained for probability x less than equals 3, right? Any doubt in this?
Sir,
No, sir.
is there any need to find the value of k in this?
Way to find the value of k? Yeah, it's the only way to, yeah.
I don't see, means I can't see anything to find the value of k, because we can see that 1 plus 2 plus 3, and if we just minus it from 1 minus 1 by 8, we are getting the answer directly.
Yeah, that way you can also do. Yeah. That's, yeah, and that way you can save your time. Yeah. Okay, so yeah, so what he is referring is, so we are given this, right? 0, 1, sorry, we're given 1, 2, 3, 4. 1, 2, 3, and 4, right? And we know that probability it's 1 by 8. It's something in terms of k. It's also in something in terms of k, and this value is also given, right? But we know is that sum of all the probability should equal to 1. It is by the property of PMF, we know. Okay, so from here you can find the value of this expression. Could be nothing but 1 minus probability x equals 4, right? And this expression is nothing but f of 3. F of 3 means probability that x will take the value less than or equal to 3. So it is 1 minus this, right? 1 by 8. So you can directly compute the value 7 by 8 without having to find the value of k as well. Okay, that's also a good approach to do. Any doubt in this, or is it clear? Anyone, any doubt? Or shall we proceed further?
Sir, how do you get 3 by 8? Sir? We have to take this 1 by 4 also in the count, no, sir, to calculate k.
Calculate k. Okay, you are talking about this method I did on whiteboard or in the solution?
No, that one, sir. Previously you shown the slide, no, sir.
Slides, okay. Yeah. So in slides, see, it's
Yes,
1 by
yes,
4
sir.
plus
4k.
Yeah. That's 1 by, right? So 4k plus k becomes 5k, right?
Yes, sir.
And 1 by 4 plus 1 by 8 is 3 by 8.
Oh, okay, sir. Okay, sir.
That goes in there, right? Okay. Anyone, any other doubt in this?
No, sir.
Okay, moving further. Okay, so it is, you are given that probability x equals x is some x over 16, where x can take the value 4, 5, minus 1, and 8. These are the 4 possible values for x. You need to check if it's a PMF or not. Okay. I think we have done enough question of this type. You can do it pretty quickly.
Sir, one question, sir.
Yes.
Sir, is mock test, considered for grading, sir?
Not exactly for grading. I think it's considered for some bonus marks. You can refer the grading doc. It's mentioned over there.
Oh, because sir, actually we didn't. Get to know about like the mock test, and we missed one mock test, sir. So there is a reason, sir. I'm asking.
Okay, so I think you need to ask from that subject sessions.
Okay, sir.
I can only tell about stats. Yeah.
Even for test, we didn't receive any mail, sir.
You will receive when we release. You will receive the mail that it has released, and after that you will have a day and a half, enough time to solve it. Right? Wednesday morning 10 till Thursday 5 p.m. So we will receive a mail as soon as we release it.
Hello, sir.
Yes.
Sir, your voice is jarring and echoing.
Is it clear now? Okay, just let me know whenever there's a trouble with my voice. Okay. Is it clear now?
No, sir, your voice is breaking, sir.
Is it for everyone or for only for him?
It's clear.
No, sir. It's clear, sir. Your voice is clear.
Okay, I think there may be some network issue from your end, Akshat. Okay, let's just. Okay, let's. Okay, one of you is still not clear with PMF. 6 have said yes. Okay. So see, my first property of PMF is that each of the values should be greater than or equal to 0, right? But as soon as I plug in -1, my probability would become -1 by 16, which violates my first property of PMF. So it's not a valid PMF, right? So these are the small things you need to take care of. The sum would definitely be 1 if you add it. The second property is satisfied, but for the first property, it's getting violated at x equals -1. Is it clear, everyone?
Yes, sir.
Okay, so that's the last question for today. Okay, so from a vessel containing 4 black and 5 white balls, 4 balls are transferred into an empty vessel. Okay, and we have defined a random variable y, which represent the number of black balls transferred. You have to find the value of random variable for which the probability would be maximum. Okay. See, in general, we are transferring 4 balls. So number of black balls could either be 0, 1, 2, 3, and 4, right? Each of them would have some probability. So you have to find that value of random variable for which you will have the maximum probability.
Sir, with replacement or without?
It's without replacement.
Hello.
Yes.
Sir, in quiz 2, we have to question from week 5 onwards, or we have to get the
1 to 8.
question week 1 to 8. Okay.
Yeah. Okay, so do you guys need more time in this or done with it?
So just 1 minute.
Okay, done now or still need more time? Okay, we can extend it for a more minute if you want.
Done, sir.
Okay. Okay, so yeah, moving further. So in general, you know that your random variable can take 5 possible values, right? If 0 black ball and 4 white balls are transferred, because in general we have to transfer only 4 balls. So it is possible that we have 0 black balls and 4 white balls transferred. In that case, the random variable will take the value 0. The second case, if 1 black ball is transferred along with 3 white balls, then your random variable will take the value 1. Similarly, for next case, if 2 black balls and 2 white balls are transferred, the random variable will take the value 2. If 3 black balls and 1 white ball is transferred, your random variable will take the value 3. And if all the 4 black balls have been transferred, your random variable will take the value 4. So what is the probability that your random variable will take the value 0? 0, it means that all of the 4 white balls should be transferred. So in general, we have 5 white balls, right? So I need to choose 4 of these 5. So that's my favorable cases. But my total number of cases would be out of complete 9 balls, 5 white and 4 blacks, I need to choose 4. So my total cases are 9C4, but my favorable ones are 5C4. So that's the probability for y equals 0. Is it clear till this step?
Yes, sir.
Yes, sir.
Yes, sir.
Similarly, for y equals 1, it means out of the 4 black balls, I need to select 1, which is 4C1. And of the remaining 5 white balls, I need to choose 3. So 5C3. That's my favorable cases. And my total cases, it remains the same. Out of complete set of 9 balls, I'm choosing 4. So 9C4, right? Similarly, for y equals 2, y equals 3, and y equals 4, they have computed the probabilities for all the possible values of random variable. And here you will see that for y equals 2, the probability is maximum, which is 0.476, right? So the answer would be y equals 2. Okay. Any doubt in these slides, anyone?
Yes, sir. Can you explain question number 4 again? Not in this slide, sir.
In this slide, question number 4.
Yes, sir.
Okay.
In this, sir, how did you assign the probability in the answer sheet?
It is given, right? The probability that he will not give any mock is 1/8, right?
Yes, sir.
But random variable is the number of mock tests given by him. So if he's not giving any mock means x equals 0, right?
0.
X equals 0 has a probability of 1/8.
Yes, sir.
If he gives one mock test, its probability is 3/8, right?
Okay.
So
yes,
x
sir.
equals 1, 3/8. X equals 2, again 3/8.
3/8 and x equal to 3. Yes, sir. Yes. Got it.
Now you can compute further, right?
Yes.
Okay. Anyone, anything else? In these slides? Everything clear?
Sir, what was the last answer? I got 2 as the answer. Means y
Yeah, 2 is
equal
the answer. Okay, y equals to 2 is the random variable. Like for this value of random
Sir,
variable, we have to max probability.
in these questions, we don't have to calculate the denominator, right? Because the denominator is going to be the same across. We just have to calculate the numerator.
Yeah, you can save time in that part. Yeah, definitely. The one with the largest value will have the highest numerator because denominator is same for all of these 5 values. It's 126 for all of these. That way you can save time in the quizzes easily. Okay, yeah. Anything else from the slides, or shall we close the slides and move to some activity questions, doubts you guys may?
Sir, I have one.
In the slides or in the activity?
Activity questions.
Okay. Let me close this one.
I'd asked in the week 6.
Okay. Activity. Okay. Which activity you had doubt?
8.
The week 9. 8. Week
Sorry,
9.
sir.
Anyone?
Week 9. 9.1. Question number. So wait a second. Question number. Question number 9.
Question number 9. Insurance salesman. Okay. So how did you approach this one?
So first I have taken 4 cases. In first case, he will not sell to anybody.
Okay.
In second case, he will sell to third person he will meet.
Okay.
In third case, he will sell to second person. In first case, in last case, he will sell to the first person he will meet.
Right.
So there are 4 cases, and the probability of x equals to 0, p of x equals to 0 will be 1/4 according to that.
No, but all these 4 events are not equally likely, right? They all have some separate possibilities.
Okay.
Okay. See, so the cases which you were referring is that he is not able to sell to any, right? No for
Yes.
first customer, no for second, and no for third, right?
Yes.
Second case you are referring is he is able to sell to third person, right?
Yes.
Third case is able to sell to second person. And fourth case is sell to first person, right?
Yes, sir.
But all of these don't have the same probability. They are not equally likely events. So you cannot go 1/4. Okay, so let's compute the probability for this. So yeah, what will your random variable x take value in such cases? It would be 0, right?
Yes, sir. 0, 1, 1, 1.
1, 1, 1. Okay. So for the first case, right, it is given to you that each of the client buying or not buying, it's independent of other clients' decision, right?
Yes.
So probability that first one didn't buy, intersection second one didn't buy, intersection third one didn't buy, right? And I know these 3 are independent. So I can use the property of independence over here, right? And I know it's 0.9.
0.9 times over 3.
So 0.729, right? Similarly, if you compute for this one, its probability would be 0.1. Its probability would be 0.09, right? And its probability would be 0.081, if I'm not wrong.
Oh, thank you, sir.
So all of these 4 cases have separate probabilities. So it's you cannot do 1/4, right?
Okay.
Okay. Yeah. Anyone any other doubt in week
Sir,
9?
yes, sir. Activity question 9.1, question number 7.
Question number 7.
Sir, I have doubt in one thing here.
Yeah.
I have doubt that one after the another, 2 cards are withdrawn from a deck of 52 cards, one after the other without replacement or simultaneously. Both are same thing.
Both are same thing. Simultaneously means we are drawing it together, right?
Yes, sir.
In that case, you consider without replacement. I think you have also asked this doubt in yesterday's
So,
session.
sir, I had not asked, but I was in the session.
Yeah.
I was actually doing this question from both methods.
Okay.
And I found
it's
that
mentioned it's without replacement, right?
Yes, sir.
Yeah. Okay. Which method you are using?
Sir, I tried it from both methods. In without replacement, if first 2 cards are withdrawn from a deck of 52 cards, a random variable 1. If exactly 1 card is face card.
Right.
So out of 12 face card, 12 C1.
Okay. First, you had 52 cards in total.
Yes.
12 are face card, right?
Yes, sir.
And remaining 40 are others, right?
Yes, sir.
Okay.
12 C1.
Right.
Divide 40 C1. Sorry, 52 C1.
Divide 52 C1. Okay.
And next one is 11 C1.
Okay.
Divide 51 C1.
C1.
First one is that, and second one, sir, 12 C2.
Yeah.
Divide 52 C2.
C2. Okay. Okay. See, here what's happening is you are choosing. Okay, you know when we use combination, right?
Yes, sir.
When we are doing without replacement. In case of with replacement, you cannot use combination.
Yes.
See, in general, what's happening here is you are selecting 2 cards of these 12, and that's your favorable cases, right?
Yes, sir.
And that's your total case. But here in this case, what you are doing is you are making cases.
Yes.
It's your first cases that you have drawn the face card first, and then you are drawing the other one. Yeah.
So when there is without replacement, we use combination, right?
Yeah.
And when there's with like when that doesn't matter is when we use combination also. We can use combination also.
With replacement case, you don't use combination generally. Okay, I will come to that as well.
Sir, if we look closely, both of them are one and the same thing.
Yeah, both of them are the one and the same thing. But
then what is
here,
the point of difference?
Difference. Okay, yeah, that's what I'm trying to tell. See, in this first approach, what he did is he first draw the face card, right?
Yes, sir.
And then he drawn the other. Okay. But it is also possible that you draw the other card first and then face card.
Yes, sir.
Right. So you need to add up these two cases.
Yes,
but
sir.
What's happening over there is here this interchange is already considered. See, here you are just selecting two cards. Order doesn't matter. You're using combination, order doesn't matter which card is drawn first. You are choosing only two cards of these two. Okay, no, exactly one should be face card, right? Yeah. So 12C1 into 40C1 divided by 52C2. See, when you are considering both of we mention it clearly. These are your favorable cases, right? Exactly
Yes,
one
sir.
face cut, right? That's your total case.
Yes, sir. 12C1 into 40C1. Sorry. Yeah.
Yeah. Yeah. See, so here what's happening is here you are considering both of the you are considering the two cards you have drawn without replacement. Order doesn't matter.
Yes, sir.
Right? That's what in the combination order doesn't matter, right? So if you open this one, what will this become? 12C1 into 40C1, 52 into 51 divided by 2, right?
Yes, sir.
Or I can write this 2 in the numerator as multiplied by 2, right? While in this case, where you are taking it individually, first you are considering the filling the first position, right? First you are drawing the first face card at the first, that your first drawn card is the face one.
Yes, right?
In that case, what's happening is, you see, and then you need to consider the second case, that the first one drawn is the other one and then the face one. You see, so when you are doing like this, you need to take into consideration the order. But when you are doing by the second approach, this your order thing is already getting considered in this case, which is missing over here.
It means both are different things.
No, both are same. You are just approaching it differently. Here you are trying to fill the first position first, and then you are going for second position. You are not filling both the position together.
If I choose the face card first and other cards thereafter, then probability for other cards changes here. So
yeah,
we will have to also consider the other case.
Yeah,
one more case.
One.
Yes.
But when you choose both of them together, it's your order thing is already compensated over here, right? By this 2, this extra 2 you are already getting here. It will already take care of all those possibilities, which comes first, which comes second.
Yes, I got it.
Okay. Anyone, anything else?
9.4, question number 7.
9.4, question number 7. Okay. Shipment of 20, similar. Okay. How did you approach this one?
Sir, I cannot understand this question. I cannot solve this question.
Okay. So what it's saying is there are 20 similar computers. Okay.
Yes.
Out of which 3 are defective.
Yes.
So if I have, let me just erase it. So this is your set of 20 computers. Okay. Out of which you have 3 defective.
17 only.
17 non-defective, right?
Yes.
Now you are purchasing 2 of these computers. Okay. So, and your random variable x is number of defective pieces you get. So when you're purchasing two, you can either get 0 defective, right?
Yes, sir.
And
One
defective, or both the defective one, right? So we are able to define the random variable till now, right?
Yes.
Now comes to the probability part. So what are my total number of cases? Out of these 20, I need to choose 2, right? Out of these 20, I can choose any 2 computer, right? In 20C 2 ways. This is my total number of cases.
Yes,
now
sir.
for x equals 0, what are my favorable cases?
17C2 upon 20C2.
Yeah. For x equals 1, I need to choose one of the defective.
3C1, yes.
And here, both of the defective, right?
Yes.
And you can compute and match with the options. Right?
Thank you. Sir, 9.3 का 4 question. 9.3 4 question.
Okay.
Sir, I cannot understand point number 3. Number of x can take is 21.
How many values your x can take? Yeah. So, okay, a random variable x is defined as length of hypotenuse. Okay.
Yes, sir.
Other two sides are determined by rolling a 6-sided dice. Okay. So when you are rolling a die, right? So in the first outcome, you will get the length of your first side, and the second you will get the length of second, right?
Yes.
So what all possible combination you can have? You can get both of these lengths as 1, right?
Yes, sir.
The first length stays 1. It second can go up to 1, 2, 3, 4, 5, 6, right?
Yes, sir.
Similarly, you can have first side as 2 and second can go from 1, 2, 3, 4, 5, 6, right?
Yes, sir.
Okay. And similarly for other values, right? 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6, right? And so on it can go. Okay. So if you notice for this value, you know the formula how to find the hypotenuse?
Hypotenuse is pi equal to base square plus perpendicular square.
Yeah, it's 1 square plus 2 square, right?
Yes.
So under root 5.
Yes.
If you compute for this here also, you will get the same, right?
Yes.
If you compute for this one, you will get root 10. And for this one also, you will get root 10. Right?
Yes, sir.
So in general, what's happening is you are choosing two numbers from 1 to 6, right?
Yes, sir.
Okay, yeah. And if you consider your all these values, right? These set of value will give you some new value, like this will give you under root 17. This will give you the value under root 26.
26.
37. But here in this lower part, we will always have its copy, right?
Yes, sir.
So only unique possible values is you can get only for these 21 values, right? The number of possible outcomes in your upper triangle.
Yes.
So length of hypotenuse only has 21 possibilities, right? But that's what third statement means. The number of values x can take is 21.
Okay. Thank you.
Okay. Yeah. Anyone, any other doubt?
Sir, week 6.
6. Okay.
Sir, like a small dot in activity, if you, for example, if you look into the activity 6.4,
okay,
like for example, in question 1 and 2, I am not understanding when to add or when to multiply. The first we have multiplied, I have multiplied, then we have got the answer. And the second question, because I've made an addition. So I'm not understanding when to do one and what to do.
okay. That's what you have to find out, the simultaneous occurrence and non-simultaneous occurrence, which one is taking place. Okay, so let's see. For the first one, out of 6 consonant and 4 vowels, right? You need to make words of 3 consonant and 2 vowels.
So it will be 6C3 into 4C2. Yeah.
Okay. We need 3 consonants and 2 vowels, right? See, in general, if you look, if I like summarize a bit question, I need to make a 5-letter word, right? Okay. So to make the 5-letter, I must have a collection of 5 letters first, right? Okay. So first I need to select these 5 letters. So in selecting this 5 letter, you have condition that 3 should be from this category and 2 should be from this category, right? So first I select the 3 of these 6. I can do in 6C 3 ways, right? Still my collection of 5 letters is not completed, right? So to complete the selection at the same time, like simultaneous occurrence, I need to select 2 vowels out of the 4, right? 4C2. So now I will have my complete collection of 5, right? And for each collection, each of these collection, right? 5 factorial ways. So if you solve it, I think it would be 5 for 20, 3 by 2, 6, 120, right?
120.
So in general, you have 120 different collection of word, right?
Yeah.
So for first collection, you can make 5 factorial words. For second collection, you can make 5 factorial word. So on. For 120th collection, you can make 5 factorial words, right? So total number of words is 120 times 5 factorial, right? It's clear.
Yeah.
Okay. Now moving to the second part. There are 40 men and 15 women in party. Okay. Each man shakes his hand only with men and each woman with all the women. Okay. Find the number of handshakes.
It is 40C2.
Yeah. See, we have 40 men, right? And 15 women. Firstly, see, total number of handshakes. Okay. So I can simplify it as number of handshakes between men, right?
Yes.
Plus number of handshakes between women, right?
Yeah, that we can do. Yeah. Got it.
Okay. Now, how many handshakes between men? So for each handshake, I need 2 people, right? So it's like I have to make all the possibilities of 2 to 2 of these 40 men.
Yes.
That's 40C2, right? That's the number of handshakes between men plus number of handshakes between women. So that's why we are adding here, not multiplying. Is it clear now?
Got it.
Okay. Okay. Yeah. Anyone, anything else? Okay, I think we can close for today. You have some math session also. in 15 minutes. Yeah. Okay, guys. Thank you, everyone.
Thank you, sir.
Thank you, sir.